Hello, everyone. So today we're going to be working on a problem pulled from the textbook for ECE 3300 or ECE 3320. So this problem is going to be 3.6-15, and the problem here states that the circuit shown in the figure contains 7 resistors. Each resistor has a resistance R. The input to the circuit is the voltage source Vs, which is shown right here, and then hello everyone. So today we're going to be working on a problem from the textbook. And so our first problem that we're going to be doing is hello everyone. So today we're going to be working on a problem out of the textbook for the course ECE 3320 or ECE 3300. So the problem that we're going to be doing today is 3.6-15. And this problem states that the circuit shown below contains 7 resistors, each having resistance R. The input to the circuit is the voltage source Vs, which is shown right here. The circuit has 2 output voltages, VA here and VB here. Express each output as a function of the input. So this is asking us to find VA and VB in terms of Vs. So the first thing that we're going to notice here is that we have 7 resistors, but we don't know the actual value for them. And so, but we do know that they're all equal and they're all equal to R. And so the first thing, I'm going to simplify this circuit as I go, but you can also simplify them all to start off with. Anyways, so to start this, I'm going to go ahead and label all of my resistors so I don't get them confused while I'm proceeding through this problem. So I'm going to take this one here as R1, R2 is going to be here, R3 will be with VA, so I'm going to write it right here. Resistor 4 is going to be my diagonal resistor, resistor 5 is going to be going through VB, and then 6 and 7 across the bottom like this. So the first thing that I'm going to do is begin simplifying this circuit to make it a little easier to solve. And so what I'm going to do is take resistor 5 and 7, and I'm going to notice that they are in series. So for a resistor in series, we know that we can just do, let's see, R1 plus R2 equals RT, or the resistance between those two. And so we're going to have R of 5 and 7, which is both of them, and it's going to be just R5 plus R7, right? So we know that both of these are just 2R, that is their value, so we can do R plus R, giving us that R of 5, 7 is 2R. Cool. All right, now that we have that, we've combined these. So instead of having 2 resistors here, it's just going to be 1 resistor going across. And then the next thing that we're going to notice from this is that R4, which is our diagonal resistor, and R5 and 7 are going to be in parallel. This is because they both are going, they're connected at these 2 nodes here, but they're not directly in a straight line. And so from that, we know that resistance through parallel resistors is going to be 1 over R, what is this? We're doing R of 4, so I'm just going to go ahead and write that. And 1 of R5, 7 equals 1 over R4, 5, 7, right? And so this is going to give us 1 over R, because that is our value for R4, plus 1 over 2R, which is our value for R of 5, 7. And this will give us, let's see, 3 over 2R. But since our equation has R on the bottom, or 1 over this resistance, we're going to have to flip it. So that's going to give us that R of 5, 4, 7 is going to be 2 over 3R. And that will be the value for that. Cool. So now we're going to have, so we've taken care of 5, 7, and 4, and we've made them into one big resistor, right? Then we're going to have something that's going to look like this. So I'm just going to go ahead and redraw this part of the circuit for you guys to make it a little easier to see. You definitely don't have to do this. Keep all of your work more organized, I guess. So now we're going to have R3. Mind you, I'm not drawing the rest of the circuit, but it's going to be on the left side of this. And then we still have R2 at the top, and then we're going to have our R of 5, 4, 7 now. From this, we know there's a node here, there's a node here. And so then we can see that R2 and R of 5, 4, 7 are in series because the current is going to flow directly through both of them from here to here or vice versa. So we can just take R of 2 plus R of 5, 4, 7 and add these up to get R of 5, 4, 7, 2. So we'll go ahead and do that. And so we're going to have let's see, R of 2 plus R of 5, 4, 7 is going to be, it's going to be 2 over 3. I want to keep that right. And then, so we know that R2 is just R, but we want a common denominator, so we can make this 3 over 3 and go ahead and add those. So we're going to get 5 over 3R. And that is going to be R of 5, 4, 7. Whoops, 7, 2. That is that. So now that we have these two added together, we can see that this is just going to become one resistor, and then R3 and R2 are going to be in parallel because there's these two nodes separating them. So then we can go ahead down here and we can take that same resistor in parallel equation and have 1 over R3 plus 1 over 5, 4, 7, 2. R, so let's write that. This is going to give us 1 over R of 5, 4, 7, 2, 3, right? Keep in mind that this R value is going to be the resistance going through VA. So we're going to use that later, but let's just go ahead and keep moving forward with this. So now we have 1 over R3 plus, let's see, what is 5, 4, 7, 2? We said was just 5 over 3R, but it's in the denominator, so I'm just going to go ahead and write, whoops, let's see, I'll just write it like this. Whoops, sorry, I'm getting distracted. Okay, so we're just going to go ahead and flip this actually, so since it's on the denominator, but we're going to have 3 over 5R, and then plus this 1 over R, which was going to give us 8 over 5R, right? Because this is going to be 5 over 5, giving them the same common denominator, so we can go ahead and add across, and then we're going to get 8 over 5R, but we do have to flip this since we're calculating R of 5, 4, 7, 2, 3, and so we're going to go ahead and make R of 5, 4, 7, 2, 3. We're going to put that over 1, which is going to give us 5 over 8R. And so keep in mind that this is going to be the resistance going through VA. So I'm going to just write a little note here that this will be our resistance through VA. All right, and so now that we've simplified that, we're going to redraw our circuit just to make sure that we're on the same page here. And so we're going to have our voltage source. Going to go up. We still have R1 here. I'm just going to draw 1 for that. We have our resistance here. We have R6 here. So like I said before, we simplified all the other resistors into this resistor up here, which is just going to be R54723, right? Okay, and so as we can see, all of these resistors are in parallel, and these are our last two resistors that we need to simplify in order to calculate the total resistance. So we're going to have R of 1 plus R of 6 plus R of 574, I guess that works too, 2, 3. And this is going to give us the total resistance, RT, right? And so we're going to have, what did we say? Okay, so this is just R, and this is just R. And then our value for 54723 is 5/8. So we can just write that in here, equals RT. And then so we can add the common denominators here. 8/8. This will also be 8/8. This one right here, but I don't have space. And so we're going to have 8, 16, 17, 18, 19, 20, 21/8 RT. It's going to be our value, right? 21/8. And that is going to be the total resistance of this entire circuit. Cool. Now, what we're going to do is take the voltage divider formula, which is going to be Vx, or I guess we'll do VA. That's what we're trying to find, right? So we're going to have VA equals VS times R of X over R. I keep writing X. This is RA, right? RA over RT. And this is going to give us that VA that we are trying to calculate. So we know VA is equal to VS. We don't know these values, so we can just go ahead and leave them like that. And then the resistance through RA is what we are trying to find, right? And so when we look at this, we simplified all of the left side, and we just were left with the resistance through resistor, what was it? Resistor 3, right? In all of this. So I said that was going to be our resistance going through this that we needed to use to find VA, which remember we made a note of right here. So we can go ahead and take that value, which is 5/8 R, and that is going to be our RA, right? So we're going to have, let's see. We're going to have 5/8 R over the total R, which is going to be 21/8 R, right? So we're going to go ahead and simplify this. So we're going to get 5/8 R times 8/21 R. Same change, flip it. These are going to cancel out, and we're going to get VA is going to equal VS times 5/21 R, right? Or I guess, yep, 5/21 VS. So this is going to be our VA value. All right, so now that we have found VA, we can go ahead and find VB, but this is going to look a little bit different because of the placement of VB in the circuit. So VB is going to be right here. And so we know that the resistance that we're going to use for R of B is just going to be R of 5. And then the total resistance through this part is going to be R57, because that's the only thing that's going to be affecting here. So with that, we can go ahead and write our equation like this. It's going to be R of 5, which equals to RB, over the total resistance, which is just going to be R of 5, 7 in this case, times the voltage. And so for that, we're going to have 1 over 2R, because that is our R value, times R of 5, 7 is actually just going to be, what is that? 2 over 21, if we go ahead and look at the circuit. And then the 2's are going to cancel out, which is going to give us a VB value of 1 over 21 times V. Okay, so that is going to be our VB value. We calculated our VA. And with that, that is going to be our solution. So one last thing before we end things off today. I know it might be intimidating when you first see the circuit with all these resistors, and especially this diagonal one here, but as long as we just take things step by step and label our resistors when solving these problems so we don't get confused, then we really shouldn't run into too many issues. All right, that's going to be it for today. Thank you guys for listening.